Welcome to Study Loop.
The problem is show that fxy is equal to x squared plus 4y squared minus 4xy plus 2 has an infinite number of critical points, and that d is equal to 0 at each one. Then show that f has a local minimum at each critical point. So first, we compute partial f, partial x, partial f, partial y. So partial f, partial x is equal to 2x minus 4y. Partial x, partial f, partial y is equal to 8y minus 4x. If we let both of them be equal to 0, we have x is equal to 2y. So for the point 2y and y can be any number. Other points like this are the critical point of fxy. Then we compute fxx. This is equal to 2. fxy is equal to negative 4. fyy is equal to 8. So d is equal to 2 times 8 minus negative 4 squared. So this is equal to 0. But for fxy, we know this is equal to x minus 2y squared plus 2. This is always greater than 2, and 1x equal to 2y. The function has a local minimum. So this proves that f has a local minimum at each critical point.